All right, so what I want you guys to notice is that this is just basically a periodic table. And the periodic table tells us a lot of information about atomic structures of the elements. So if I look at this, what our activity was to kind of diagram the Bohr Rutherford model of atoms and the different elements. So the first one is hydrogen, right? So there's a lot of information in the periodic table if you want to know about hydrogen. So hydrogen has an atomic number of 1, okay? The symbol is H, and then the atomic mass is 1. So if I come over here, there's a lot of information that I know. Well, if the atomic number is 1, then that means that it has, let me zoom in so we can really take a look at it. That means that it has 1 proton. Okay? Now, if it, well, let me draw it a little bit. Let me undo this and I'll zoom in a little bit more. So that means that it has 1 proton. So this was your assignment yesterday. Okay? Now if it has 1 proton, and if the atomic mass is 1, well, first of all, if it has 1 proton, I know that it has 1 electron. So you were supposed to put 1 dot here. So for hydrogen, we know that it had 1 proton. That's a plus symbol. And we knew that it had 1 electron. And then the number of neutrons, we're not sure. Remember that the atomic mass is the sum of the proton and the neutron. Remember also that the neutron also acts as a buffer, because 2 protons, if they have a positive charge, they'll push away from each other. So you need a buffer somewhere in the middle. And so the number of neutrons, we'll come back to that. We'll come back to that one on hydrogen. Hydrogen and helium are kind of their own thing. So now let's go to helium, which is way over here. If I go to the periodic table, okay, now helium is a different animal. It has an atomic number of 2, right? This is the atomic number 2. That tells me it has 2 protons, but it has an atomic mass of about 4. So what that tells me is that it has two protons, right? And it also has 2 neutrons. Why? Because if it has an atomic mass the atomic mass comes from the number of protons plus 2 neutrons. Remember, they're about the same mass. So the atomic mass is 4 for helium, where the atomic number is 2. And we could even fill in the entire chart there. We could write it exactly how you see it here. So we could say the atomic number is 2 and the atomic mass is about 4. And if we go back to our hydrogen, we could do the same thing here. The atomic number is 1. Whoops, that's not a great one. And then the mass is 1. Now, if I come down to lithium and I look on the periodic table, I get that lithium has an atomic number of 3 and a mass of about 7. So I'm going to say that my atomic number for lithium is 3 and my mass is 7. So what that tells me is that I have 3, oh, I didn't finish helium, did I? If I have 2 protons, how many electrons do I have? 2. So I've got to put 2 electrons in here. So remember, the electrons has to equal the total number of protons. All right? So if I get to lithium, I have 3 protons. Let me zoom in a little bit more. So I have 3 protons. Now, if my atomic mass is 7 and I have 3 protons, oh, that is not a good. How many neutrons do I have? 4. Very good. So the periodic table tells me a lot of stuff. It's so hard to write. I should have found, I had a separate model thing to do. And then my neutrons is equal to 4. Now, if my protons equals 3, how many electrons do I have? 3, right? Because you want to have an equal charge. Now, this first ring, N1, this can only have 2 electrons. That's the most that first ring can hold. So where do I put the third one? Yep, on this ring right here. That's it. So now the periodic table is written in a very specific way. So what do you think the atomic number of this one is? 4. And then we're going to look to see what the atomic mass is. So you're right, it's 4, and the atomic mass is about 9. So I'm going to come over here. My atomic number is 4, and my atomic mass is 9. So that means, because the atomic number is 4, that means I have 4. Oh, I'm hitting the button, that's why. Why is it doing that? And then, yeah, real quick, go out the door here. So if the atomic mass is 9, then that means I have 5 neutrons. But again, how many electrons do I have? 4, because I have 4 protons. So I'm going to put, how many can I put in this first ring for N1? Only 2, right? And then the rest have to go outside. So I have 1, 2, 3, 4. What's this next one? Boron, which will be 5. So then I come over here, and now it's way over here though, okay? And the atomic mass is, what do you guys think? Close to 10 or 11? Yeah, we could say 11. That's fine. So we say it's 11. The truth is, the reason that number is an average is sometimes it's 10, sometimes it's 11. So how many protons do I have? 5. How many neutrons do I have? 6. Okay, cool. So now how many electrons will I have? 5. How many go in this first ring? Only 2. How many go on the second ring? 3. So I'm going to say 1, 2, 3. Okay? Does that make sense? Carbon is 6. The atomic mass is 12. That means that I have 6 protons, 6 neutrons, and that means I have 1, 2, only 2 in that first ring, 3, 4, 5. Oh no, got a little happy with the pen. 5, 6. Okay? And those are all my electrons. Now nitrogen is 7. Oxygen will be 8. So I'm going to skip down to one of these bigger ones. Let's do aluminum. Aluminum is something that you guys know. And so I'm going to skip down to aluminum. Now, aluminum's over here. That has an atomic number of 13 and a mass of about 27. So I'm going to say that this is atomic number 13. And the atomic mass is about 27. Now, I picked this one on purpose. So that means that I have 13 protons. And how many neutrons? 27 minus 13, which is 14. So remember, these two numbers here, protons plus the neutrons will always equal your atomic mass. The atomic number always equals the total number of protons, and whatever you have for protons is the same number of electrons. What's the most that that first ring can hold? 2. Now the next ring can only hold 8. So I've got 1, 2, 3, 4. Wow, those are too close together. 3, 4. Make sure that they look separate. 5, 6. 7, 8, 9, 10, and then I'm going to have 11, 12, and 13. Okay? Does that make more sense now? Is there anybody have any questions? All right. So I just wanted to go over that. The first ring can hold 2. The next ring can hold 8. The ring after that can hold 8. And that's all we did. We only did up to argon. Okay? We'll talk about the grouping and how the periodic table, but I just want you to kind of process this for now. All right?